Okay, so you can go on. So it's Mr. C5, Google Meet. Okay. Just trying to look at something for you guys here. Okay, so I'll screen share with you. Rada, can you just grab me that book? I appreciate it. It helps me out. Thank you. Okay, so let us look at question number 2. This is page in the workbook, page 112. Okay, so let's read through it together. It says gaseous iodine monochloride. So that's this. ICl. Okay, it just says iodine, which means there's only one of them. If there was more than that, let's say there was 3 of them, it would say triiodine. There has to be a prefix in front of it. There's no prefix in front of it. It means there's only one. Mono in the middle means one chloride. Exposed to heat. Second, guys. Okay, so it's exposed to heat and it forms 2 gases. Iodine and chlorine. Look what I just did. Those 2 elements are diatomic. So keep in mind, whenever you see the word iodine by itself, Iodine, when it's written, it's not simply written I, it's written I2 because it's one of those special NOF ClBr It's one of those special elements that comes in pairs. Guys, we're watching me, right? Not flipping tabs. Okay. So I'm going to need more room here. I'm going to put this a little farther down. Okay, so it's a little harder to figure out, but once you figure out the equation, then it's just a matter of balancing. It says here, first of all, you're supposed to classify it. So this is a breaking apart. What do we call breaking apart? What's the proper name for it? Yeah, it's decomposing, so it's called a decomposition. Ooh. Decomposition. Notice we already talked about this before, that a decomposition is breaking apart. You need energy to do that. You have to add energy. Notice it mentions that at the very beginning. It says that this gaseous iodine monochloride is exposed to heat. It's another way of saying that heat's added from the very beginning. Heat's added. So it is endo. It's endothermic. I just put endo. Okay, B. Solid iodine. And, okay, solid iodine. And aqueous solutions are formed. Okay, so notice the word used is formed. The iodine and the sodium bromide are formed. That means that they're products. It's kind of a trick. They actually go on the right side of the equation. So we'll come back to those. How are they formed? When liquid bromine is added to sodium iodide. So those are our reactants. So we have bromine. Bromine is one of those elements that come in pairs. And then sodium iodide. And it produces, it says here, it produces what's formed? The solid iodine. So I2 plus sodium bromide. NaBr. You should know how to find the formulas by now for those. Okay, so what's happening? If you take a look, that's a nonmetal. That's a nonmetal. They're trading places. So one element's being replaced. It's called single replacement. Single replacement. Okay. Now I've got to balance this. I forgot to balance A. I'll go back to it in a second here. But let's take a quick look. I'm going to do this. I'm going to do it quickly. Put 2 there. Let's see if this works. Does that work? Double check because I'm doing it quickly, so it's easy to make mistakes, but it should work. Good. Go back to this. Just put a 2 in front. Now it's balanced. C. Electrical charge triggers the breakdown of sodium azide, which is NaNN3. NaN3. It breaks down. That's another way of saying decomposing. To form sodium metal. Sodium metal is just Na. If you see any mention of sodium metal, lithium metal, magnesium metal, just write down the symbol. In this case, Na. Nitrogen gas. This is by itself. Is that correct? Okay. No, it's diatomic. It's in that list. Included in this list is hydrogen as well. Okay. I just mentioned it. It's breaking apart. It's decomposing. And it mentions, by the way, in order to get this triggered, you need a spark. That means you're adding energy to break it apart, which means it's endothermic. And balancing. I'll put a 3 there, 2 there, and a 2 there. That should balance it. Okay. Now I'm going on to the rest of the page. D. Burning crystalline naphthalene. Naphthalene is how you pronounce it. C10H8. It's a hydrocarbon. Hydrocarbon. In air, what does that mean? What's in air? Oxygen. That's the hint. Oxygen contains a certain percentage, or air contains a certain percentage of oxygen. Produces carbon dioxide. This is always the case. When you have a hydrocarbon or even an alcohol reacting with oxygen, you're always going to get carbon dioxide and water. This is called a combustion, which is always exothermic, always releases heat. Heat's released at the end. It's exo. Okay. I'm going to do a quick balance. So 10 here. Let's see if this works. 4 here. Okay, so do you agree so far the carbon and the hydrogen are balanced? It's a 4, by the way. You agree with that? Okay, good. So all I have to do is make sure the oxygen's balanced. So there's 10 times 2, which is 20 oxygen, plus the oxygen here. 4 times 1, which is 4, for a total of 24. I need 24 on the left. How do I make it so there's 24 on the left? What do I put here? Good, times it by 12. Okay, good. Combustion reaction. Anytime you have a carbon and a hydrogen molecule, it's called a hydrocarbon, or an alcohol. Alcohol has an added extra oxygen to it. Reacting with oxygen, it's going to release energy in the form of heat and a little flame. Okay, notice they use the word burning. That's your clue. When you see the word burning, that means it's reacting with oxygen. That means it's a combustion reaction, burning. Okay, E. Phosphoric acid reacts with barium hydroxide. So this is an acid. And it reacts with barium hydroxide. Just look it up. Barium, I think, is +2, right? I think it is. Just confirm that. I'll look at barium. Yeah, it's 2. Good. So the equation is Ba brackets. And that forms a solid of barium phosphate. I'm going to write it down quickly here. It's Ba3PO4 bracket 2 plus water. I need more room here, so I'm going to move it. Plus water. I'm going to write it like this. HOH. Different way of writing water. Why? That's to remind you that each water has 1 hydrogen and 1 OH. You can write it the other way if you want as H2O, but this is a quick way of balancing. I'll do that now. I'll categorize it in a second. But what I want to do to balance this type of reaction, what type of reaction? There's an acid and a base. When you have an acid and a base, the way to balance it is to write the water as HOH and balance the H. See if the H can be balanced. Well, there's 1 H here. There's 3 there. Is that going to work? We'll see. We'll come back to it. I don't know if that's going to work. I'm going to try this. You'll see why in a second. I am going to put a 6 here. This is trying to save us time. See if it works. I might be wrong. What does that mean? That means there's now 6 H's on the right. How do I make 6 H's on the left? Put a 2. Okay? Now, why did I do that? Because now I can say there's 6 OH's on the right, and I can make it so there's 6 OH's on the left. 3 times 2 means 6 OH. Why didn't I just try to go with 2 OH? Because you have to find a number that the smallest number that both of these go into. There's 3 hydrogen here. There's 2 hydroxide here. The smallest number they go into is 6. That's why I tried to come up with a total of 6. It was a bit of a guess, and I was right. Okay, so what type of reaction is it? It's an acid-base reaction or neutralization, either one. Or neutralization. What do we know about those types of reactions as far as endo or exo? Does it release heat or does it take heat in for it to start up? Yeah, it's good. It's this here, this water molecule that makes it exothermic. It forms a strong bond. Whenever you have a strong bond forming, it releases energy. So this outweighs everything else, and you get plus energy. So it's exo. Okay. Next, precipitate of iron 3 sulfide. Fe2S3. Look what it says. Forms. It's even tricking me. It's a product. It's not a reactant. In a solution of magnesium nitrate. Okay. When what? How do you get this? What comes next? You have iron 3 nitrate. So that's FeNO3 bracket 3 plus magnesium sulfide. So plus MgS. That's where you get the form part. The form is the product. You get Fe2S3. Plus, it says here, yeah, magnesium nitrate. Thank you. Magnesium nitrate is this. Okay. Okay. So what type of reaction is this? This is the clue. Compound plus compound. Yeah, just double check. Get it? Double check. It's double place. No? Okay. So just make sure those two change places, and they do. Fe changes places with the magnesium to join up with the nitrate. So that is a double replacement. We don't know whether it's X or endo. Could be either. We're not sure. G, room temperature, tin 4 hydroxide is poured into hydrogen bromide. So tin 4 hydroxide is poured into hydrogen bromide, HBr. This is a base. This is an acid, so it's an acid-base reaction. We'll come back to that. Introduce tin 4 bromide plus water. So we're going to write the water like I did before as HOH. So this is an acid base or neutralization. Therefore, it's exothermic because of this here. Okay, balance it quickly. We have 4 hydroxide here. That might be our clue. Let's see if that works. Put a 4 there. That gives us 4 hydroxide on the right, which is what we want. and also 4 hydrogen. Put a 4 here. Now you're done. Okay, I didn't balance the one above, but let me do it quickly here. Okay, so getting back to this acid-base reaction, that's the way you balance it quickly. Change the water into 1H and 1 hydroxide. H. When a solution of sodium carbonate is added to a solution of aluminum chloride. I think CO3 is -2, right? Just double check that. It's added to, it is, yeah. To aluminum chloride. I'm going fast here, right? Yeah. I'm just writing down the formulas because I'm crisscrossing it in my brain, right? You guys are trying to save you time here, but you should know how to do that by now. Added to a solution of aluminum chloride. Aluminum carbonate forms. So it is 2, right? Thank you. In sodium chloride. Sodium chloride is what we call table salt. It's just what we refer to normal salt. So compound plus compound. What does that remind you of? Yeah, it's probably double replacement. Let's just double check. That means these 2 metals should switch places, and they do. Okay, so it is double replacement. Okay. Balancing, I'll do it quickly here. Let me just, this is just a trick. Put a 3 there, see if that works. Put a 2 there, see if that works. Put a 2 there, see if that works. Put a 3. Oh. Give me a second here. Na2CO3, AlCl3, Al2CO3. I don't have to put the 2 here, eh? Yeah. But I do have to put the 6 here, yeah. Thank you. Didn't get any sleep at all for the past 2 days. So. I don't know. I don't know. Because usually I don't have a problem. It's Wednesday, right? So Monday night, I just laid in bed till about 4, and I got maybe an hour's sleep. And then last night, same thing. I don't believe in that. I usually don't have a problem. Really? I'll try that. Thank you. That more natural. I appreciate it. Okay, so here's, let's flip to page 115. Let's go. This is predicting the products. You basically know how to do it, but I'm going to give you some clues. Let's go through. I'm going to give you clues for this page, and then you're going to complete it, classify it, do the same thing, and then balance it. Okay, so it says here, first one is a hydrocarbon plus oxygen. What kind of reaction is that? Combustion. So the products are always this. That's always the products. In fact, that's what's coming out of the exhaust pipe of your car when you burn gasoline, because it's a hydrocarbon. You're getting this, which is changed into carbon monoxide by your converter. And then you get little droplets. You ever seen the steam? I've mentioned this before, the steam coming out of the exhaust? That's water. Probably dirty water, but it's steam. You can see it on a colder day. Okay, next reaction, chlorine plus Ki. You've got an, here's your clue. You got an element plus a compound. What do you think? Single replacement. Now here's what happens. Let's look at this. I am going to write over this in red just to highlight what's being, well, that's messy. Write it in red. I'll write this in red. Why did I do that? Because those are nonmetals. And in a single replacement reaction, if you have a nonmetal, single nonmetal, that will replace the nonmetal in the compound. So the Cl and the I will switch places. Right? So you'll end up with this. You'll end up with KCl. I'm going to give this one to you. Plus I. You think that's right? Can I leave it as I? Very good. Okay. Next, I'll give you a clue for C. C is going to be a synthesis. You're going to form one compound. That's all I'm going to tell you. I'm going to leave that up to you. Okay. D, double replacement. Let's write it down. AgNO3 plus Li2. Notice what I'm doing. I'm coloring the metals in red. You see that? Why did I do that? Because the metals in a double replacement switch places. That's your clue. I'll leave that up to you. They switch places. So the Ag is now going to go, the Ag is going to connect with this. And the lithium will then connect with the nitrate. Okay. E, what's your clue? Decomposition. It's going to split apart into two separate elements. F. So E is decomposing. And F. Very good. Acid base. So with an acid base, you're always going to get water. You produce blank plus HOH. What's the blank going to be made up? In this case, it's going to be made up of the barium and the nitrate. Okay? And don't forget, check that. Make sure that I'm right with the formula. Okay, G is single replacement. The Zn is going to trade places with the H. The positive ions switch places. G, positive ions switch. I just put switch, but you know what I mean by that, switch places. H is synthesis. They come together to form, well, that's your clue. Synthesis. They come together to form one compound. Let's see if you can get that. I is acid base. I'll leave that up to you. J is, what kind of reaction is that? Yeah, combustion, because they just change the order. It doesn't matter. It's a hydrocarbon plus oxygen. Combustion. And K is going to be, compound plus compound is double replacement. What's going to switch places? Which elements? Very good. Excellent. Okay, I'll let you finish that. Do the same thing with number 1 on page 15, as you just did before, except you have to complete the right side first. Okay? Yeah. Yeah. No, we wanted to talk to me about stuff. I need some coffee, guys. Okay. So listen, you don't need the computers to do this. So close the computers. You need the workbook. Guys, you should be, once I finish lecturing, working on a workbook, just close the computers. You don't need it. Yep. Great for what? It's posted, right? What do you want to talk about? Okay, give me a second. Yeah. Were you looking at my notes? Or are you looking at something else? On the notes? Go ahead. I'm getting paranoid. I just don't want you. I already got balled out. Yeah. What was it you wanted? Oh, I'm not too. Did you check Google Classroom? I went over everything up to Sunday. I'll look at it again tonight. So maybe just shoot me a quick email later tonight. And I can't. It will change, but I can't. I mean, if it's it won't be. But if it's a substantial change on the report card, I can have it reprinted. It's a bit of a pain, but I don't think it's going to be. It'll be added on to the next one. And if you're not concerned with that, then keep it at that. Yeah. Let me, guys. I'm just going to get some.
What's that? That's not 40 now.
Okay. So, whoa. So, one second. Today's Wednesday, I have you Friday. And I have Tuesday and Thursday. Test is Thursday. What I'm giving you now is an assignment, okay? So, it will be due the day, I don't want to do that to you, but I think you have enough time. Day of the test. Later. If you want to hand it later that day, that's fine. So Thursday. I will assess this, okay? I'm going to go through it thoroughly. So here's the thing. I will count it, because I'm going to go through it, I'll count it more than a regular assignment. You may put it in the test bin. It'll count as a small, minor quiz. So do a good job on it. Should be straightforward. So on an acid basis. I think I'll do that. It'll be tested. I'll put it in the test bin, but it'll be for like a small quiz. Okay? So you got a chance to get it done all the way up to the test day at the end of the day. Did you have a question?
Oh,
Okay. Did I not get it back? No problem, downstairs.
give
Okay.
yourself one, Daddy.
Give me a second.
I'll give you one.
I got one.
You got one?
I didn't even take any just straight on just like something regular. You know. I see it.
I got that. I want to finish the whole part before classes.
No, I never. No. So good. I don't.
I know I did it November 25th, and he still gives me the marks for